All right, let's extend that pediatrician from example 1. And not only can we do the less than, but we could also do between. So remember, I'm going to keep beating the same drum over and over again. What did we talk about? If I have the probability, what's another word for probability? Proportion. What's another word? Area under the curve, right? I mean, I'm just going to keep beating the same drum over and over again because the last one talked about proportion. This one talks about probability, but remember we said these are all synonymous. So if we're going to talk about one, we use the same method to find the other. This is, we want to figure out girls' heights. What's the probability or that proportion or that area under the curve between 35 and 40? So that's what we're going for there, okay? So if I want to figure out the probability of those heights being between 35 and 40, remember, we're using this x value that we have. That x represents our data. So our data is between 35 and 40. Now, I want to make sure, again, I just want to really make sure that you get what's going on here. So let's look at these z-scores. All right, so for right now, I want to make sure you understand the concept of what's happening. So z is equal to the x minus the mean over the standard deviation. But because this one's in the middle, I'm going to have an upper z-score and a lower z-score because I want to figure out what's between those two. All right, so my upper z-score is going to be z is equal to 40 minus my mean from the other side is 38.72. My standard deviation, it's the same example, is 3.17. So my z-score here, if I plug all that in, you get a 0.40. So a positive 0.4, is that going to be to the right or to the left of the mean? To the right because it's positive, right? Yes. Right of the mean. Is it a full standard deviation away? No, a little less than half, right? So it's pretty close to the mean. Not even a whole standard deviation away. Okay, so then my lower here, z is equal to 35 minus 38.72. This is literally what we did on the other, so we don't even have to plug that in. We know this is negative 1.17 because that's just like our last example. And what else do we know? To the left, just a little over one standard deviation to the left, right? Left of the mean. And this is a good indicator about what this looks like. So if I'm going to look at, oh my gosh, my bell curves, you guys. I don't know if that's any better. Yeah. So my mean is still 38.72. 38.72. And then I know it's not even a full standard deviation away. It's really tight and close here to get to 40. I know this one is over one standard deviation because this is where we saw previously to get to my 35. Now between these two, this is the area, this is the proportion, this is the probability, right? We'll just keep saying the same thing over and over again. So if I truly want to find the probability between 35 and 40, we're going to go back to StatCrunch. Now look at what's happening here with StatCrunch. In our StatCrunch, we have this as standard and we have the option of between. Now, it looks like between's currently selected, but it's not. I don't know why it kind of does it backwards like that, right? Now the between is selected and you can tell because my probability down here is between two things. We still have 38.72 because that was my mean and this is my standard deviation from our last problem. Now I'm going to close out of this and we're going to retype it because I want you to remember we go to Stat, Calculator, Normal. We should write that down on our notes. I'll do that on this problem. Our mean is that 38.72. Our standard deviation is 3.17, but if you have a problem that's doing the same thing over and over, then you can do that. I'm going between 35 and 40. And we're going to compute that. And look at what this is. I'm going to pull mine over here. Look at our graph. Here is the mean right down the middle. And it's just a little bit over. Here is the same shading is our same shading. Do you see what's going on there? I want you to remember, an area is the same thing as what? A probability. Good, which is the same thing as a proportion. Yes. That's what this number represents. A probability, a proportion, an area under the curve of that normally distributed curve. That's what we're getting here. So our proportion, we're going to go 4 out again, these nice 4 decimal places. 5365. 0.5365. Oh, you can't see all of that. All right. And that is the proportion. That if we were to go back to our data chart out of 1 and we added all those up, it's going to be very similar to that, very close to what that is. All right. So I didn't put the steps on the previous example, so I'm going to put them on this one over here. So StatCrunch steps. You're going to do stat, calculator, and then normal. And then you put all the info in. Stat, calculator, normal. Then you decide, is it less than, greater than? Is it between? I'm going to scoot this over again. Right? So here are my choices for between, the standard. If it is less than, if it's greater than, if it's going to be to the right, or if it's just to the left. It just depends on what it's being asked. Okay? All right. You guys, we're rocking through this. I'm so impressed.